Hi guys, my name is Nonkazimulo Nzoza and I'll be taking you through exercise 7.6 on page 132. We're testing for the difference in population means for independent samples. Okay, so the question reads as follows. To compare two programs for trained industrial workers to perform the skilled job, 20 workers are included in an experiment. Of these, 10 workers are selected at random and trained using method 1, and the remaining 10 are trained by method 2. After completion of the training, all workers are subjected to a time and motion test that recorded the speed for performance of a skilled job. The following data is obtained. So the mean for method 1 is 19.1, the standard deviation for method 1 is 4.82, and the mean for method 2 is 23.3, and the standard deviation for method 2 is 5.56. And then the question says, is there a significant difference in the mean time scores for the two training methods? Use alpha is equal to 0.05 and assume that the populations have equal variances. All right, so let me put my book down. Now, what you needed to note in this question is that they gave you the population, but they didn't give you the variance of the population. They gave you a standard deviation of the samples. So we don't know what the population variances are, but we're told to assume that the population variances are equal. So the first thing you do is you can label your x bars. Okay, this is the formula we're going to use here is t is equal to x bar 1 minus x bar 2 minus delta over sp squared over n1 over n2, and that's in a square root. You can do the denominator differently if you just say sp multiplied by 1 over n1 plus 1 over n2, because you know that if you take the sp, if you square root the sp squared, it becomes sp. So then it's the same difference. Okay. Can rub this off. All right, so the first thing you can do just to make life easier for yourself is label the different methods. So what I usually do is that I'll say method 1 is x bar 1 and it's going to be m new m, yeah, I'm going to call it mean 1, and then method 2, what am I doing? Method 1, method 2, x bar 2, just call this mu2. So the first thing, you know that with hypothesis testing, you've got 6 steps. You state your hypothesis, then you state your test statistic, your rejection region, you calculate your observed value, you calculate your p-value, and then you state your conclusion. So with the hypothesis, they said to us that is there a significant difference? So they didn't ask if something is greater than or if it's less than. So we know immediately that it's a two-sided test. And so our hypothesis is going to look like this. It's h0, mu1 is equal to mu2. And the alternative hypothesis, mu1, is not equal to mu2 because they said there's a significant difference between the two means. And then your test statistic is this one up here, so that's the same. T is equal to x bar 1 minus x bar 2 minus delta 0 over sp squared. And remember, according to your preference, you can choose how you write your denominator, but it's still going to give you the same answer at the end. And then your alpha, remember, they said test at alpha is equal to 0.05. But because it's two-sided, we're going to divide alpha by 2. So it's going to be 0.025. So we know this follows, okay, let me write it here. It follows a Tn1 plus Tn2 minus 2 distribution. And so we know that sample number 1 has got 10 people, sample number 2 has got 10 people. So we're going to say T10 plus T10 minus 2, that's T18, and then we're testing at 0.025. And if you go to your table, you'll find that this is equal to 2.101. And so the third thing you do is state your rejection region. So we're going to reject H0. Since it's two-sided, we have to write both cases. if T observed is greater than T18, 0.025 equal to 2.101, or if T observed is less than negative T18, 0.025 is equal to negative 2. There we go. And then number 4, we're calculating your observed value. So the first thing you're going to do is get your SP, and that's given to you in the formula sheet. SP squared, they give you SP squared in your formula sheet, is equal to N1 minus 1 multiplied by the standard deviation of the sample, the variance of the sample, N2 minus 1 multiplied by S squared over N1 plus N2 minus 2. And so there, we're going to say 9 multiplied by 4.82. Remember, they gave you these values in the question. So you put them in as follows: squared, and then 10 plus 10 minus 2 is 18. And then SP squared is going to equal to 27.073. So after we calculate SP squared, we put it into our formula. Remember, we said that we labeled our x1 and x2. So then method 1 was x1 and method 2 was x2. So then we're just going to follow that throughout your whole working out. And so method 1, the mean was 19.1. Method 2, the mean was 23.3 minus 0 all over the square root of 27.073 multiplied by 1 over 10 plus 1 over 10. And your T observed value is going to equal to negative 1.0805, sorry. And so then next what you do is you calculate your p-value. And I'm hoping that you've got this down, that you've been following. So I'm going to erase this because I won't have enough space that side to write the p-value. Especially with the t distribution, you know that our p-value is in between two different proportions, and so probabilities, and so that gets a bit complicated. So I want to make sure that we get that right. So we're doing step number 5, calculating the p-value. All right, and so we said we are going to reject H0 if T observed is greater than 2.101, or if T observed is less than negative 2.101. And we find that our T observed value is negative 1.805. And so when you look at your distribution over here, so if this is negative 2.101, this is positive 2.101, we see that negative 1.805 is actually falling in here. And so we already know that we're actually going to fail to reject H0 because it's not here, it actually falls in between. So it's not, our bounces are preventing negative 1.08 to be the side of the side, so it's here. And so with your p-value, you're going to say 2p, remember because it's two-sided, is equal to t's less than negative 1.805 is equal to 2p. And remember, your t-table works with greater than values, but because this is negative, then we change the sign to become greater than 1.805. This, we can take this to our table, and you'll find that at t18, 1.805 is between, remember, you write your smaller probability this side and your bigger probability this side. And always remember that, because you remember your smaller probability will have a bigger number, and your bigger probability will have a smaller number. So don't confuse that. And so I'm going to say half the p-value, because remember, because it's two-sided, you want to have to multiply each side by 2. So that helps you not to forget to do that. We're going to find 0.025 and 0.05. And when you multiply the side terms, multiply by 2, multiply by 2, and you get 0.05 is less than p-value, it's less than 0.01. And so What was your offer in the beginning?
Nanga,
Yes.
just before you go on, in the step P-value, yeah. Can you just notation-wise get rid of the negative?
Yeah.
No, not negative, sorry. The equal sign in between P and the bracket. It doesn't belong there. It belongs before the 2.
Where am I getting? What did I do wrong?
Yeah. On top. That step. Do you see it? Yeah.
From 2P in bracket 2.
So the same way you wrote it on the second step.
I see.
Yes. And then get rid, yes. And then the
So
left-hand
P-value.
side, yes. The P-value is equal to 2 times.
I was supposed to say
The P-value is equal to 2 times the probability. Yes. Yeah.
this is right.
Yeah.
Yes.
I said 2p is equal to p. That's what I did.
2P is equal to bracket.
Oh,
Yeah.
ooh, wow. All right. So I must tell them about that. Okay. Guys. Oh, Nizwileke. Guys, what I wrote here, this is what I wrote. I said 2p is equal to probability.
No.
Is that what I did? I didn't even have the probability outside the bracket.
Yeah.
Oh my goodness gracious me, guys, don't do that. And I said t is less than negative 1.805. Guys, that is wrong. Don't do that. So what you're supposed to write is that your p-value is equal to 2p, and then the rest of your notation. So make sure that you don't get this notation wrong like I did, okay?
Can you also please explain how you got the half, like on the third step?
Yeah.
Half p-value. Okay, what I said, okay, according to my thinking, if I'm correct, right, guys, is that because your p-value is between two different values, you're gonna have to multiply each side by 2. So
So before we get there,
before we get here,
like how did we move from p-value to half p-value?
because it's 2p here,
Yeah.
and so I know that the p-value I'm gonna get that they're in between is actually, okay, actually I can't explain that.
You divide by 2.
I divide this,
Yeah.
Both sides.
You divided both sides by 2.
I divided both sides by 2.
Yeah. So before you even wrote the step about half p-value, you would have needed to divide the left-hand side and the right-hand side by 2, right? Okay. Meaning the other side would have been half p-value is equal to the thing without the 2, the probability of t being greater than 1.805.
So what if,
Do you want to maybe track back? So
Yeah.
maybe erase the step, this one.
this one?
Yeah, so that you can also understand it. Yeah. So basically, your left-hand side of that equation,
Yes.
left-hand side, just write p-value, just write p-value.
Yeah.
Don't start a new equation. On that equation that you already have, yes, there, write p-value. Yeah. Then now, you want to make sure the 2 that's in front of that disappears. Then how do you do that?
You divide it.
Yes, so divide by 2. So it's going to be, what are you going to be left with? On both sides. Mathematics says what you do on your left, you must do
On your right. Yes, that's how you get rid of the 2. Okay. And then it becomes half p-value
Yeah.
is less than this.
And why are we doing that? We're doing that because your left-hand side in the equation you just wrote is concerned about half the p-value.
Okay.
Yeah.
Okay. And then that's why I have to multiply this by 2 again.
Yes, because at the end of the day, you don't want half the p-value, you want
The p-value.
p-value.
Okay. Alright. I'll see.
And that only happens if, don't erase it.
Okay.
You have it, yeah.
Okay.
That only happens if you've got a two-sided test. So you wouldn't have to worry about
Dividing this by 2 if it wasn't
Yeah,
two-sided.
because even your
Okay.
first statement wouldn't have had times 2.
Alright. Okay. So you guys are busy following throughout that whole process, ne? Yeah, we make mistakes. And so your notation is p-value is equal to 2p. Then multiplied by t is less than negative 1.805. And okay, to get to this step, we have to divide this by 2. Meaning, if you divide this side by 2, you must divide this side by 2. And 1 divided by 2 is equal to a half. And that's how we get to half p-value. And then the smaller probability we get and the bigger probability we get, we multiply those by 2, because at the end of the day, we're concerned about getting the p-value, not half of the p-value. All right. So the smaller probability was 0,025 and the bigger probability was 0,05. And I always say, just remember that the smaller probability goes on your left and your bigger probability goes on your right, because this number will actually be greater than this number. So don't forget that. And so then when you multiply this by 2, and you multiply this side by 2, because you're concerned about getting the p-value at the end of the day, you're going to get 0.01 on this side and 0.05 on this side. And you will find that your p-value is greater than alpha. Because remember, what was our alpha in the beginning? It was 0,025. And so for your conclusion, say since t observed value is, it's not less than, where is it? It's not less than negative 2,010. Remember our observed value here, it is over here. It's not less than negative 2.10. And your p-value is not less than alpha, which was 0,025. Remember, we got our p-value, it's greater than 0,05 and less than 0,01. And so we fail.
Alpha 0.05.
Sorry, guys.
No, that's right. But no, you said alpha 0.025, but it's 0.05.
Yeah, alpha is equal to 0,05.
Oh, guys, oh, sorry. This was the original
Alpha, yeah.
This was the original alpha. And so alpha is 0,05, yes. And so your p-value is actually greater than 0,05 and less than 0,1. Remember, 0,05 times 2 is 0,1. Sorry about that as well. And so we fail to reject H naught. Fail to reject H naught and conclude that at the 5% level of significance, there's insufficient evidence. Okay, I'm running out of space. So there's going to be insufficient evidence to state that the mean scores are different for the two different methods. And that's your exercise 7.6.